All right, so we are resuming our lesson at example 6 for section 1.1. And this is giving us a real world example. I'm talking about angles and rotations. And just keeping in mind, this is more about converting and tying it into what we call angular velocity, okay? Angular velocity is where you are spinning in a circle, rotating, right? Those are, it's called angular velocity because you're describing the rotation. So whether it's a revolution, degrees, radians, you're describing the rotation that's taking place. So it says here, a constant angular velocity disk drive spins a disk at a constant speed. Suppose the disk makes 480 revolutions per minute. Through how many degrees will a point on an edge of a disk move in 2 seconds? Okay, so a couple things we have to do here is we have to convert. It wants it in terms of degrees, and it wants it in terms of seconds. How many of you have had physics or chemistry and maybe your teacher said train tracks or conversion tracks, or do any of those words sound familiar? Okay, well, that's what we're doing. We're doing a conversion track. Okay, so we're gonna have to take 480 revolutions per 1 minute. And our goal is to convert it into degrees per second. So you got to cancel out your revolutions and cancel out your minutes and turn them into seconds. I like to start with the top of the track and go from there. So revolutions. So I need to go from revolutions to degrees. 1 revolution is how many degrees? 360. So we know that 1 revolution, and notice revolution is going to go in the denominator. That's because the only way to cancel out something is it has to be in the numerator and in the denominator. So 1 revolution is 360 degrees. Does that make sense? So now revolutions can be canceled out. And now I'll have my degrees. Okay, next I need to get rid of minutes. Well, currently minutes are in the denominator. So I'm going to need to put minutes in the numerator. How can I go from minutes to seconds? What is their relationship? There's 60 seconds in a minute. So we know that 1 minute is 60 seconds. So notice that I can cancel out the units of minutes because they're in the numerator and in the denominator. The units that I'm remaining are degrees and seconds. And what units did I need? Degrees and seconds. Okay. So now all you're doing is multiplying. So we have 480 times 360. So 480 times 360 over 1 times 1 times 60. So we're going to do 480 times 360 divided by 60. Turning on Sylvie. So 480 times 360 divided by 60. And we get 2,880. So this is 2,880 degrees per second is how fast it's moving. Okay, so that's per 1 second. It says if I want to move 2 seconds, what would I need to do? Multiply by 2. So after 2 seconds, therefore would be 2,080 times 2, which equals 5. Well, I wrote plus 2 because I'm smart. There we go. And we get 5,760. And a bunch of extra numbers that I don't know why I wrote. Okay. That's going to be like the most straightforward way of converting is taking what you have and finding out what your end game is. Okay. So things to keep in mind is that a revolution is 360 degrees, right? 60 minutes, not 60 minutes, 60 seconds is 1 minute, 60 minutes is 1 hour, 24 hours is 1 day. And so just being able to convert between those things using the train track method would be the best way and probably the most direct way. Okay, I think visually it just shows that you're eliminating the units and you know that you're canceling them out. And then it also lets you remember what you're multiplying and then what you're gonna have to divide by. Okay? Questions about it? No? All right, then that is it for 1.1.